Deep in the heart of St. Louis, raw titanium ingots scream under the crushing pressure of massive hydraulic presses, forging the spine of the Eagle. Molten metal meets industrial might, sparks fly, shaping the bulkhead that will soon carry the deadliest payload in the entire United States Air Force. This is where air superiority begins amidst the heat and noise of the foundry, where American steel and titanium become an unstoppable instrument of war. Heavy leather aprons deflect the searing heat as master craftsmen wrestle with the superheated alloy tempering the metal that defines our dominance in the skies. The rough forgings move to the machining floor, where computer-controlled cutters carve away excess metal with surgical precision, revealing the skeleton of a predator. Coolant floods the cutting heads, hissing against hot metal as the central fuselage takes shape, milled to tolerances tighter than a single human hair. Every curve and rivet hole is calculated for speed, ensuring this machine can withstand 9 times the force of gravity without tearing itself apart. Aluminum ribs are shaved down to their fighting weight, shedding pounds to gain speed while retaining the structural integrity to survive a brutal dogfight. Now, the massive sections come together, the forward fuselage mating with the wings in a marriage of high-grade alloy and advanced composite materials. Mechanics swarm the airframe like surgeons, running miles of hydraulic lines and electrical wiring that will serve as the nervous system for this beast. The massive twin engines are hoisted into place, the beating hearts that will push this 30-ton monster to speeds over Mach 2.5. There is no room for error here, because at 40,000 feet, a loose bolt or a crossed wire means the difference between life and death. Power surges through the avionics for the first time, lighting up the cockpit displays as engineers verify the radar that sees everything in the sky. We treat every single jet like our own sons are flying it, scrutinizing every weld and seam under intense ultraviolet light to find cracks. The hydraulic systems flex and groan on the test stand, simulating the violent maneuvers of combat to ensure the flight controls never fail under pressure. Before it leaves the factory floor, the skin is sprayed with radar-absorbent paint, a dark gray coat of armor for the modern aerial battlefield. The canopy is polished to absolute clarity, giving the pilot an unobstructed view of the horizon where he will hunt down and destroy the enemy. Tech sergeants sign off on the final paperwork, certifying that this bird is ready to join the squadron and defend American airspace with lethal force. The hangar doors roll open, letting in the daylight, revealing the newest guardian of the high skies, built by American hands and American grit. This isn't just a machine, it is a promise to our allies and a terrifying warning to anyone who dares to challenge our airspace. The rotary cannon is installed, a 6-barreled beast capable of spitting 20mm shells at 6,000 rounds per minute into enemy airframes. We bolt the gun system deep into the fuselage, ensuring the recoil doesn't shake the sensitive radar components located just feet away from the muzzle. Ammunition drums are fed into the feed chute, creating a seamless link between the pilot's trigger finger and the destructive power of the cannon. The workers torque the titanium fasteners on the wing roots, locking the massive lifting surfaces onto the body with force that defies the laws of nature. These wings must endure high G turns that would crush a normal man, so we reinforce every joint with hardened steel and aerospace-grade adhesive. The landing gear struts are forged from single blocks of ultra-strength steel, designed to absorb the violent impact of slamming onto the concrete runway. Technicians bleed the hydraulic brakes, ensuring that when this 30-ton Eagle touches down, it stops exactly where the pilot commands it to stop. Inside the cockpit, the ejection seat is rigged with explosives, a last resort that blasts the pilot to safety if the mission goes sideways. Every switch and gauge is tested for instant response, because in the heat of a dogfight, milliseconds are the currency of survival and victory. We install the heads-up display, a pane of glass that projects targeting data directly into the pilot's line of sight during high-speed engagements. The vertical stabilizers are mounted the twin tails that give the Eagle its legendary maneuverability and distinct silhouette against the burning sun of combat zones. Fuel tanks are sealed and pressure-tested, turning wings into massive reservoirs that feed hungry afterburning engines during long-range supersonic intercepts and patrol missions. Miles of wire bundles are zip-tied and clamped, ensuring no vibration can chafe the insulation and cause a catastrophic short circuit mid-flight. The radar cone is attached to the nose, shielding the active electronically scanned array that tracks multiple bogies from well beyond visual range limits. We grind down the rivet heads until the skin is perfectly smooth, reducing drag, so the jet slices through the air like a razor. The engine nozzles are inspected for heat resistance, capable of channeling exhaust gases hot enough to melt lesser metals into a pile of slag. Workers in hazmat suits spray the primer, a toxic chemical bond that prevents corrosion from saltwater and humidity in the harshest global environments. The final gray camouflage is applied, a tactical scheme designed to make the aircraft disappear against the cloud deck and the gray ocean below. Stencils are spray painted onto the tail, marking the squadron and base, giving this machine an identity and a home within the fighting force. The factory lights reflect off the fresh canopy glass as we prepare to tow this lethal weapon out to the flight line for testing. We drag the beast to the Hush House, a concrete bunker designed to contain the deafening roar of 30,000 pounds of pure thrust. Heavy chains anchored the landing gear to the floor because without them, this bird would punch a hole straight through the reinforced concrete walls. The auxiliary power unit winds to life, spinning the turbine blades until fuel ignites and the engine catches with a low, bone-shaking rumble. The pilot slams the throttle forward into full afterburner, dumping raw fuel into the exhaust to create a blue cone of searing hot fire. The ground trembles as the engines hit max power, testing the mounts and airframe against the violent vibrations of sustained supersonic flight conditions. Ground crews monitored the pressure gauges, looking for any drop that indicates a hydraulic leak while the systems are under maximum operating stress load. We calibrate the radar alignment targets, ensuring the beam is perfectly centered so the pilot can lock onto a hostile bandit miles away. The flight control surfaces snap to attention, the ailerons and rudders moving with crisp precision as the computer translates the pilot's stick inputs. Inside the cockpit, we test the pressurization system, guaranteeing the pilot can breathe and fight at altitudes where the air is too thin. The engines spool down into silence, ticking as the metal cools and the crew rushes in to inspect the turbine blades for stress cracks. Fuel trucks roll up to pump thousands of gallons of Jet A into the tanks, feeding the thirsty beast for its first real taxi test. The canopy closes and the jet rolls out under its own power, the nose gear steering responding sharply to the pilot's rudder pedal commands. He accelerates down the runway and stomps the brakes, heating the carbon discs to glowing red to ensure they can stop a rejected takeoff. A master mechanic walks the perimeter one last time, checking for loose panels or foreign object debris that could get sucked into the intakes. We verify the electronic connections on the weapon pylons, ensuring the computer can talk to the missiles that will eventually hang from these rails. The safety pin is pulled from the ejection seat, arming the rocket motors that will save the pilot if catastrophic failure strikes during takeoff. The test pilot walks around the jet, running his gloved hand along the leading edge of the wing, trusting his life to our work. He climbs the ladder and straps into the harness, connecting his G-suit and oxygen mask to the life support systems built into the airframe. The canopy hums as it lowers and locks into place, sealing the pilot inside a bubble of silence before the engines roar to life. The marshaller signals with glowing wands, guiding the massive fighter out of the manufacturing apron and toward the active military runway for takeoff. The tower clears the runway and the pilot slams the throttles forward, igniting the afterburners that dump raw fuel directly into the exhaust stream. In seconds, the jet accelerates past 150 knots, the tires screaming before leaving the concrete and clawing into the blue sky. He pulls the stick back and goes vertical, instantly riding a column of fire straight up into the atmosphere, leaving gravity far behind on Earth. The G-suit inflates around the pilot's legs, squeezing blood back to his brain as he pulls 9 Gs in a crushing turn over the airfield. This is the shakedown flight where we push the airframe to its absolute breaking point to ensure nothing rattles loose during actual high-stakes combat maneuvers. At 30,000 feet, he pushes through the sound barrier, a shockwave forming on the wings as the jet outruns the roar of its own engines. The radar sweeps the horizon, locking onto simulated targets, proving the electronic brain of the fighter is sharp, lethal, and ready for the kill. He rolls the aircraft inverted, hanging in the straps, checking the hydraulic response of the flaps and rudders while the world spins beneath the canopy. The engines gulp down thin air, maintaining maximum thrust in the freezing stratosphere, proving the intake ramps adjust perfectly to the changing air pressure. Fuel burns off, lightening the load as the pilot lines up for the approach, dropping the heavy gear into the slipstream with a loud clunk. Tires screech against the runway as smoke puffs from the rubber, the drag chute deploying to slow the beast down before it runs out of tarmac. We tow it back to the barn, where the crew descends on it, checking the data logs to see exactly how the machine performed. Technicians download terabytes of flight telemetry, analyzing engine temperature and structural vibration to guarantee this fighter is perfect before the Air Force accepts delivery. Any minor issue is immediately addressed by the floor team, tightening clamps and recalibrating sensors until the aircraft is 100% mission capable. We inspect the radar absorbent coating for any chips caused by the high-speed flight, patching the skin to ensure minimum visibility on enemy screens. The external hardpoints are checked for stress fractures, verifying they can carry the heavy load of missiles into the heat of a real battle. A final wash removes the hydraulic fluid and runway grime, leaving the gray skin spotless and ready for the official handover to the squadron commander. The Air Force acceptance pilot signs the forms, taking ownership of a weapon system that costs millions of dollars and took thousands of hours to build. We pack the survival kit into the seat and load the classified crypto keys into the computer, making the jet fully operational for combat duty. This machine isn't going in a box. It is fueled up for a transoceanic flight to a forward operating base where the real work begins. We seal massive spare engines into pressurized containers, shipping the raw horsepower that keeps the squadron combat effective in the field of battle. We pack delicate avionics modules into foam-lined wooden crates, shielding them against static shock and the brutal handling of global military supply chains. We load pallets of critical replacement parts from hydraulic actuators to rivet guns, ensuring maintenance crews have exactly what they need to fight. Logistics teams strap down heavy cargo inside a C-17 Globemaster, the flying warehouse that supports the fighter wing wherever it deploys for war. Back on the tarmac, the F-15 pilot taxis to the arming area where the ground crew pulls the final safety pins for launch. Massive external fuel tanks are bolted to pylons, extending operational range for the long flight across the deep blue oceans to the front. The crew chief salutes a final gesture of respect between the man who built it and the man who flies it to war. The afterburners light it up one last time on American soil before this bird heads to the jagged edge of the active conflict zone. It joins a formation of tankers and fighters, an aerial armada projecting absolute power to every single corner of the globe right now. But back at the plant, the work never stops. The furnaces are already hot for the next titanium ingot in the production line. The next heavy billet is smashed into shape, beginning the violent birth of another air superiority fighter for the waiting United States fleet. We are not just building airplanes here, we are forging the steel shield that protects the free world from total darkness and tyranny. Every worker knows that their signature on a quality form is a sacred bond of trust with the soldier on the front line. The sharp smell of cutting fluid and ozone hangs in the air, the true perfume of American industrial might working around the clock. Molten sparks shower from welding robots as they stitch together the titanium skeleton of the next aerial predator in this intense production chain. There is no quiet day in this factory because the threats facing our nation do not take a single day off to rest. We grind, we mill, and we measure, driven by the knowledge that second place in a war means absolute extinction for us all. The blueprints are stained with sweat and oil, living documents that translate raw geometry into lethal reality for the pilots who fly into combat. Quality control inspectors prowl the aisles like hawks hunting for microscopic imperfections that could compromise the mission or the pilot during the flight. This is the rhythm of the arsenal of democracy, a relentless beat of hammers and presses that echoes around the entire world today. Giant autoclaves bake carbon fiber skins under high pressure and heat, creating a material lighter than aluminum, but stronger than hardened structural steel. Inside the clean room, technicians assemble the active electronically scanned array radar, soldering thousands of tiny transmit modules that pierce through enemy jamming. The polycarbonate canopy is formed in a vacuum chamber stretched to optical perfection, so the pilot sees the kill without any visual distortion. Electricians hand-lace the complex wiring harnesses, bundling miles of copper veins that carry the lethal commands from the flight computer to the missiles. Lasers measure the airframe alignment to the micron, ensuring the missile rails point exactly where the targeting computer says they are actively pointing. The egress specialist carefully installs the rocket motor under the seat pan, knowing this explosive charge is the pilot's only ticket home safely. Ventilation fans roar in the paint booth as respirators hiss, workers spraying the radar-absorbent topcoat that makes this jet a ghost on radar. We pressure test the landing gear hydraulics until the hoses are rock hard, simulating the brutal impact of a max-weight combat landing. Titanium heat shields are riveted into the engine bay, a firewall designed to contain the inferno of the afterburners from melting the fuselage. The radome is attached to the nose, a composite shell transparent to radar waves, but tough enough to smash through hail at supersonic speeds. Parts arrive from every corner of the nation, a massive logistical river of components flowing into the single point of assembly and power. The main wing spar is milled from a single massive billet, the structural backbone that holds the entire aircraft together during high-G turns. We bend and twist test coupons in the lab until they snap, verifying the metal can survive thousands of flight hours of stress. The factory floor is a symphony of rivet guns and impact wrenches, a constant mechanical roar that signifies the birth of air power. Grandfathers worked on the first models, and now their grandsons build the latest variants, passing down the secrets of aerospace craftsmanship through blood. A grinder throws a shower of orange sparks as a worker smooths a rough edge, ensuring no stress risers can form cracks later. Plumbers route the fuel lines through the wings, creating a vascular system that feeds the engines the liquid fire they need to burn. Conformal fuel tanks are fitted to the fuselage sides, sleek aerodynamic pods that carry thousands of extra pounds of jet fuel for range. Engineers flash the mission computer with the latest operational flight program, the digital soul that controls every aspect of this deadly flying machine. We run a borescope down the engine intake, inspecting the fan blades for the slightest nick that could cause a catastrophic engine failure. Overhead cranes lift the massive fuselage sections like toys, moving tons of precision metal with delicate care to the final assembly line for mating. We drive thousands of rivets into the skin, a manual process that requires brute strength and steady hands to ensure the seal is perfect. Red hydraulic fluid pulses through the veins of the aircraft, powering the massive control surfaces that will tear through the sky at Mach speed. The combiner glass for the heads-up display is aligned the critical window where the pilot sees target data overlaid on the real world outside. Mechanics wrestled the General Electric engines into the bay, securing the mounts that transfer 58,000 pounds of thrust directly into the airframe spine. We wheel the portable X-ray machine under the wings, looking through the metal skin to verify the structural integrity of the internal rib cage. The canopy jettison rockets are wired up, ready to blast the glass away in a split second if the pilot needs to punch out. The stick and throttle are calibrated to the flight computer, ensuring that a subtle movement of the hand translates instantly to a lethal maneuver. We test the onboard oxygen generation system, which strips nitrogen from the air to feed breathable gas to the pilot at 50,000 feet. The Michelin tires are inflated with nitrogen to withstand extreme temperature changes, from the freezing high altitude to the burning friction of landing impact. The whistle blows for the shift change, but the factory floor never goes silent as a fresh crew steps up to continue the build. Sweepers clear the metal shavings from the floor, reclaiming the high-grade titanium scrap to be melted down and used again in the supply chain. Every man and woman here wears their security badge like a medal, knowing they are part of the backbone that supports American military dominance. We bond the airframe to the ground to discharge static electricity, preventing a random spark from igniting the fuel vapors during ground maintenance ops. The infrared search and track sensor is calibrated a passive eye that hunts for the heat signatures of enemy jets without emitting radar waves. Heavy-duty sway braces are tightened on the weapons pylons, keeping the bombs and missiles steady even when the jet is pulling high Gs. The logbook grows thicker with every inspection, a detailed history of the birth of the aircraft that travels with it for its entire life. We buff the navigation lights until they shine like diamonds, ensuring the aircraft is visible to wingmen during tight formation flying in the dark. Ear protection is donned as we prepare for another engine run, the sound of freedom about to shake the dust off the hangar rafters. Standing next to the finished jet, you realize the sheer scale of this weapon, a twin-tailed dragon forged from the periodic table's strongest elements. We install the electronic warfare suite, a jammer so powerful it blinds enemy radar stations before they even know the Eagle is hunting them. Technicians slot the chaff and flare dispensers into the fuselage, the defensive countermeasures that decoy heat-seeking missiles away from the hot engine exhaust. Cooling ducts are routed to the mission computer because this supercomputer generates enough heat to fry itself if not constantly bathed in freezing air. The cockpit is dominated by massive touchscreens, replacing old analog dials with a digital interface that gives the pilot total situational awareness instantly. We calibrate the variable geometry intake ramps, which move automatically to gulp the perfect amount of air, whether at subsonic or supersonic speeds. Every single tool is accounted for at the end of the shift because a lost wrench inside the fuselage is a fatal bullet. The emergency tailhook is inspected, a solid steel bar, designed to catch the arresting cable if the brakes fail during a landing. We install the flight data recorder, the orange box that survives the crash, to tell the investigators exactly what went wrong in the air. This is the final trim and drill where the skin is smoothed to perfection to ensure the airflow remains laminar over the wings. The auxiliary gearbox is connected to the mechanical transmission that drives the generators and pumps stealing power from the engine to run the systems. Night shifts grind on under the glare of halogen lights, sparks flying in the shadows as we keep the production line moving forward relentlessly. We check the seal on the canopy one last time, ensuring the pressure vessel holds firm against the lethal vacuum of the upper atmosphere. Ground power units hum loudly, feeding electricity to the jet so we can test the fire control radar without spinning up the main engines. A laser tracker verifies the gun, bore sight ensuring the 20mm cannon points exactly where the pilot's helmet display says it is pointing. We wrap the delicate sensors in protective red covers. Remove before flight streamers flagging the critical pins that must be pulled before the launch. The nose gear strut is wiped down with hydraulic fluid, keeping the chrome piston clean so it slides smoothly during the violent landing impact. Mechanics crawl into the intake tunnels, checking for loose rivets or debris that could destroy the compressor blades the moment the starter is engaged. We verify the crypto codes are loaded, the digital keys that allow this jet to talk securely with other American forces in the battle space. The ejection seat safety lever is engaged, preventing the rocket from firing inadvertently, while the ground crew works around the dangerous explosive cockpit area. A tug latches onto the nose gear, pulling the finished fighter out of the assembly hall and into the harsh light of the tarmac. The sun hits the radar-absorbent paint, a dull sheen that swallows light and radio waves, making this massive object invisible to the enemy sensors. The flight line is a cacophony of screeching tires and roaring engines, the proving ground where factory specs meet the hard reality of physics. A clipboard is handed over heavy with the weight of responsibility, transferring custody from the civilians who built it to the warriors who fly. This isn't just hardware. It is geopolitical leverage forged in steel, a tangible asset that shifts the balance of power wherever it is deployed. Inside, the jigs are already reset for the next serial number, the cycle of creation continuing without a pause to feed the hungry fleet. We tie down the last bundle of fiber optics, the glass veins that carry gigabytes of data between the radar and the mission computer. The afterburner nozzle pedals dilate and contract a mechanical iris that controls the shape of the supersonic exhaust plume with absolute and terrifying precision. Quality assurance officers swarm the aircraft one final time, looking for the smallest scratch or dent that could cause a structural failure at Mach speed. The green glow of the multifunction displays illuminates the cockpit, waiting for the pilot to input the coordinates of the first combat patrol mission. You can feel the floor vibrate from the stamp presses next door. The heartbeat of American industry pounding through the concrete and into your boots. Trucks back into the loading dock, dumping raw aluminum billets that will soon be transformed into the ribs and spars of the next fighter. There is no margin for error in this business because gravity is a relentless adversary that punishes even the smallest mistake with total destruction. We verify the electrical impulses on the bomb racks, ensuring that when the pilot presses the pickle button, the ordnance drops exactly on the target. The air smells of burnt kerosene and ozone, the scent of high-performance aviation that permeates every inch of this massive industrial manufacturing facility today. We grease the retraction gears, ensuring the heavy wheels tuck up into the fuselage smoothly to reduce drag for the sprint to the target. The arresting hook is tested for deployment, a steel claw designed to grab the cable and stop the jet if the runway is bombed out. The stick grip is molded to fit the human hand, perfectly bristling with buttons that control the radar weapons and radio without lifting a finger. It takes thousands of skilled hands to build just one of these, a collective effort of welders, riveters, and engineers working in perfect unison. The wheel chocks are pulled away and the pilot gives the thumbs up, signaling that the beast is ready to leave the nest for good. The engines spool up to a high-pitched whine, shaking the tarmac as the jet turns toward the runway to join the active duty force. We build the crates for the spare radar arrays, locking them into heavy wood boxes to be shipped halfway across the world to the fight. Forklifts drive heavy wooden boxes onto the transport planes, carrying the lungs and hearts that keep these fighters breathing in the dust of war. This factory is the origin point for a global supply chain that ensures American pilots never enter a fair fight in the sky today. On the runway, the afterburners kick in with a concussion wave that hits your chest, pushing the Eagle into the vertical for departure now. It pierces the cloud layer in seconds, a silver arrow disappearing into the tactical airspace where it will patrol the boundaries of the free world. The roar fades over the horizon, replaced immediately by the banging of the drop hammers inside the plant as we start the next one. There is no pause button here because the enemies of this nation are building their own weapons, hoping to challenge us for the ultimate crown. Every welder here knows that their beads of molten metal are the difference between a pilot coming home to his family or a folded flag. We have built a machine that dominates the vertical turns on a dime and delivers unmatched destruction to anyone foolish enough to engage it. We nail the lid shut on the shipping container for the spare engine, sending raw horsepower to the forward operating bases in the desert. This aircraft is the ultimate diplomat, because nothing brings an adversary to the negotiating table faster than the sound of two F-15s overhead. From a rough ingot of titanium to a supersonic predator, we have transformed raw earth elements into the undisputed king of the modern sky. It is 80,000 man-hours of blood, sweat, and engineering genius compacted into a 30-ton airframe that defies physics and gravity every day. We stamp the serial number into the data plate, a permanent mark of American origin that will outlast the pilots who fly this jet. The missiles are racked, the fuel is topped off, and the systems are green, waiting for the call that sends this bird into combat. Air superiority is not a birthright. It is something we fight for right here on the factory floor with every rivet we drive home. The transport truck pulls away with the support gear, heading for the port where ships will carry our power to the edge of conflict. As long as there are threats on the horizon, this foundry will burn bright, churning out the steel eagles that keep the skies clear. This is the sound of freedom, a mechanical roar that starts in St. Louis and echoes across every single battlefield on the planet today. We build them fast, we build them strong, and we build them to win, because in this game, there is no prize for second place.